Hello everyone, today we will be going over Lewis structure diagrams. So let's begin. The first thing you want to take into consideration when drawing these out is put the one with the least electronegativity in the middle. Typically that is what you do, but whenever you see carbon, carbon will always go in the middle. So let's write that out as C in the middle, and we have four atoms of H. So we put an H here. We'll put an H here. We'll put an H here. We'll put an atom of hydrogen right here. Okay. So what is the second thing you want to do? The second step is you would want to write out the amount of valence electrons around it. So we know hydrogen is in group 1. So therefore, hydrogen would get 1 valence electron. So we can draw one right here, draw one right here, right here, right here. I just draw it on the side closest to the central atom, so it's easier to connect. Alright, now here is a little bit more tricky. So, when we get to how many valence electrons are in C, so you know, from group 3 to 13, most of them contain valence electrons of 3. However, once you get to group 14 to 18, this is where you'd have to do more math, because whenever an atom is in a group after group 12, you have to subtract the group number minus 10. So if carbon is in group 14, how many valence electrons would carbon have? So you would have to do, since carbon is in group 14, you would do 14 minus 10, and that would get you to 4. To the equal sign. Yep, so that will get you to 4 valence electrons. So therefore you would draw 1, 2, 3, and 4, and that's how many carbon would have. Now in order to put these together and make them into pairs, we would have to connect them. So to connect them, you would look at the lone valence electrons here. Like for example, all of these are lone ones, so these are easier. So here on this one, this would be connected to this. This carbon valence electron will be connected to this, connected to that, and H would be connected to C electron again. Alright, so that is the Lewis structure, but now how do you know how to check that? So there's a check called an octet, which basically means that an atom should have 8 electrons after you connect them on the Lewis structure. So let's check chlorines. So let's check carbon's octet. So here we have C, and we know that this is 1 electron. This is 1 electron, so that's 2, that's 3, and that's 4. But remember, they've been connected to the hydrogen electrons. So that would now be 5, 6, 7, 8. So carbon has its 8 electrons, and it passes the octet check. And now, hydrogen is an interesting one, because hydrogen only needs 2 to complete its octet, you might say. So, if you look at each hydrogen atom, you see that's 1 electron here, and that's another. So it completes its 2 octet. It only needs 2 to complete its, well, octet, you might say. So here again, it has its 2, it has its 2, it has its 2. Alright, so hydrogen would have its octet checked too. So it would be 2 for all of the hydrogens, and that's how you know they passed the octet check. Now a final check you could perform is you could do the total number of valence electrons. So how would you do this? You would do, The total number of valence electrons in hydrogen is 4, and the total number in carbon is 8. So we would write it out as 8, and you would subtract 8 by the number of pairs. So we have 4 pairs here, which is then you then have to multiply it by the number of electrons, the total number of the electrons being shared in those pairs. So in one pair equals 2 electrons. If there are 4 pairs, you would therefore have 8 electrons, and that is how you know that this Lewis structure works. Alright, now let's take a look at the second example. In this example, we have BCO3. So we would start off the same way we did with our last example. Which atom has the lowest electronegativity here? Now that is going to be boron, since it is more to the left of the periodic table. Bottom left has the lowest electronegativity. So we put boron in the middle, and we put chlorine around it. Cl and another chlorine atom. Alright, now how many electrons does boron have? Well, boron is in group 13, and 13 minus 10 is equal to 3. So boron would have 3 electrons. But remember, don't get confused by this. You only subtract by 10 from group 13 onward. Okay, so let's draw the valence electrons in boron. So boron is in group 13, and 13 minus 10 is equal to 3. Remember that this rule only applies to elements from group 13 to group 18. You must always minus 10 and you'll get the number of valence electrons. Alright, now to find the number for chlorine, we know chlorine is in group 17, and 17 minus 10 is equal to 7. So when drawing this out, remember you must always draw a single electron around the atom before you add another one. But what I mean by that is you put 1, 2, 3, 4, 5, 6, 7. Alright, now you would do the same with the other ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Alright, now when connecting these, we see that boron has this pair which can be connected, and it has 2 others over here. Alright, so boron will go with Cl. There's another unpaired, and there's another unpaired electron which Cl and boron can share. Now we can do the octet check. So for the octet check, B, does it have all 8? Well, here's the trick here. Elements in group 13 typically do not need all 8 electrons. They only need, for example, boron only needs 6 valence electrons. There's the exceptions, like helium and hydrogen only need 2. Boron and aluminum typically only need 6. So we'll count up if boron has its 6 valence electrons. 1, 2, 3, 4, 5, 6. Boron passed its octet check. Now let's Cl, chlorine. So chlorine has 1, 2, 3, 4, 5, 6. And then here there's a pair which we know equals 2 electrons, and 6 plus 2 is 8. And it is the same if you count it up for the other 2 atoms of chlorine. So chlorine also passes a check. Now the final check you can do is the total valence electron check. We know that boron has 3 valence electrons, and we know that chlorine has 7. And if there are 3 atoms of chlorine, it will be 3 times 7 for chlorine equals 21 plus 3 because boron has 3, and that equals 24 total valence electrons. So 24. Now in this example, there are electrons on the outer atoms, so we would have to encounter those first. So now we can calculate the total electron method. We can start doing our total electron method by subtracting. So we have 24 minus, and now we will look at the pairs outside the atom. So in this one, the chlorine pairs. So we have 1, 2, 3, 4, 5, 6. This would not count because it's connected to the boron at the moment. So we have each chlorine has 6 electrons on the outside. So therefore 6 times 3 is equal to 18. And we know 24 minus 18 is equal to 6, which you would then subtract. And now you would take into account the pairs which are the electrons which are connected with each other, from the boron valence electrons which are connected with the chlorine valence electrons. So we know there's 3 connections between the 3. So you would then do 3 multiplied by 2, which gets you 6. And since that equals 0, you are now done. That is Lewis structure diagrams for everyone.